Hi, welcome to Fortnite Power Videos. This is DC here. In this video, I'm going to discuss a specific feature called Eas Id, which is present in the Icode Slix2 tag. These are the things I'll be discussing in this video. Eas Id is a 16-bit number. So the value of this ID can be read as well as changed. However, there is no command to read the Eas Id. So you don't see a command like read Eas Id in the documentation. However, there is a specific command called write Eas Id to change the Eas Id. This ID is most often used with the Eas alarm command. So in my earlier videos, I showed you what the Eas alarm command does. So whenever this command is sent, any tags in the vicinity of the reader will respond with the 256 bits of the alarm bits. Now using this Eas Id, you can target a specific tag. Now if you got a multiple tags, you can send this alarm command along with the Eas Id. So any tag with the matching Eas Id will respond with the 256 bits of alarm bits. Now again, this is a feature available in this tag, and how we use it, it's all up to our skills and our requirements. The Eas ID is also affected by the Eas password. If that Slix2 supports Eas password. So we have seen this Eas password can be used to protect any changes to the Eas, whether you enable the Eas or disable the Eas, or you lock the Eas, plus whether you're allowed to change the Eas ID without the password is all controlled by the Eas password. And there's also a feature called Eas lock, which we have seen in my earlier videos. If the Eas is locked, you cannot change the Eas ID. So more or less, this Eas ID will go along with the other Eas features. Now my advice is, when you open the datasheet of this Slix2, search for the word Eas ID, and you just have to collect all the information from the document, so to understand how the Eas ID is used. Now I have been using two softwares in all my videos on IS1 5693 and Icode tags. I've been using a software that uses the PN580 board along with Arduino, and this software was useful for embedded programmers. And also I've also been using software that's written for OmniKey 5022 reader writer, and this is for the desktop developers. From this video onwards, so any feature discussed will work in either of these software. More or less the screens are the same in both the softwares, so if you see this video once, you know how to work with these two different softwares. The most important thing in this Eas ID command is that the option flag. This plays a very important role here. So you have to understand this option flag is used some kind of a parameter to distinguish what to do. So with this background, probably now we are ready to see how the Eas ID works, and these are some of the commands you have to go through that. As I mentioned before, it's more or less used along with the Eas alarm. So in this command structure, the value of the Eas ID is passed. Now when the Eas ID is passed, it can be, you can send it either just a part of the Eas ID, like the lower 8 bits, or you can send the entire 16 bits. So assume that we are sending just the lower 8 bits, then any tag with the matching lower 8 bits will respond to the Eas alarm. So again, this documentation mentions about the option flag. See, when the option flag is 0, this command behaves just like the way the ES alarm work with the Icode SLI and SLIX. Now ES ID is used only when the option ID is equal to 1. Now when it is 1, the ES ID is passed, and as I mentioned before, there is no command to read the ES ID. The ES alarm command itself is used to return the ES ID. So again, it's clearly mentioned here, when the option flag is 1, this is where all the ES ID feature will kicks in. When option flag is 1, if we do not pass any ES ID, that means when the length mask is 0, we don't pass the ES ID, the tag returns the 16-bit ES ID. Now that is how you read the value of ES ID. Plus again, you have to pass how many bits of ES ID you'll be sending in the command, and it is you can't send any number of bits. It has to be either no ES ID, where it is the mask length is 0, or the 8 bits where you send the lower byte of the ES ID, or the 16-bit. So this will be either 0, 8 or 16. If it is 0, nothing will be present here. If it is 8, you're going to send 8 bits of ES ID. If it is 16, you're going to pass 16 bits of ES ID. So I'll be using OmniKey 5022 software, and as I mentioned before, you can also do the same thing using PN580 as well. So you can see I've connected my OmniKey 5022 reader writer, and I'm going to activate, and you can do all this initial stuff. Now I can hit this alarm. Now here, if you look at the command, this alarm command is sent without the option flag set to 1. Now this is the same command structure. If you look at here, same command structure used with the SLI and SLIX. I can also pass this command in address mode. Only thing is, you're targeting a specific tag. So first thing I'm going to do is go to the NXP information tab and hit the get command. So here we know that some of the information here are useful. You can use information to lock certain section of the screen. So at this moment the ES is not locked, it's set to no, and this is the feature bits of the tag. It says ES ID supported is yes. Now we know SLX2 supports EX ID. I've not seen a tag where this ES ID supported is set to no. I've not come across that yet. So go back here. Now this is I'm sure this is not locked. I'm going to change the value of ES ID to, say for example, B1 C1, and hit the write. Now there is a command called write ES ID. You can see the documentation, and we got a success. Now this is how you change the ES ID of the tag. So in order to read this, you'll be using the ES ID. So I'm going to place this tag again, activate, get the system information. You don't have to do get system information unless you want to read here. So I'm going to read the ES ID. The way you do that is you must have the option flag set to 1. This is the first thing you have to do. You can have either address ticked or unticked, doesn't matter. Now you'll be using the mask length. When no mask length is sent, and if you hit the alarm, so you get, if you look at here, you get the value of the ES ID C1 B1. That's what is sorry, B1 C1. Yeah, it is, when you hear B1 C1, the B1 is the lower byte and this is the higher byte. So you get the data you get from the tag is always the lower byte first. C1 and B1. So that is how you read the ES ID. So just see that, make sure the option flag is set to 1 and the mask length is set to 0, and hit the alarm, and this is the way you read the ES ID. You can change anytime, so I'm going to change this to C2 and say write. Now so this is it's an error, sorry, option flag is not set here, sorry. So write, yeah, so now we change the ES ID to C2. I'm going to read it, so you can see that we are read C2 B1 is written. Now I'm going to enable the entire ES feature with the password. Now keep in mind, enable password is like a one-way operation. You can't undo it. So unless you got some extra spare tags with you, you don't have to try this. You can just see my videos. So now I'm going to show you how the protect ES password work with ES ID. Now this tag I've already got the ES password protected, and after this I'm going to show you how to do this on a brand new tag. First I'm going to read in what's the value of ES ID. So set the option and say alarm. The ES ID is B1C3. I want to change this to say B4. Now keep in mind, any write operations using 5022 reader writer, you must have the option flag removed. Whereas if you are using the PN5180 board, you can still have the option flag set. It is the way the IS-15693 protocol works, and some of the feature is not possible to do that using 5022. So I'm going to write. Now we got an error. It is because the tag is already protected with the ES password. So in order to make changes, you first have to send the ES password. Now I'm going to do that now. I'm going to get the random number, and the ES password for this tag is set to 5, and you know that we have to use the address mode. Set. Now the password is set. Go back here and say write. Now you can see that we are able to now write the ES password, ES ID. So now I'm also going to lock the EAS. Now this is going to be repetition now, but however it's it's good if you're not done this before. So I would like to lock the EAS itself. So when you lock the EAS, it's this button here. It locks the enable disable. It also locks the EAS ID. So before you lock, you have to first send your EAS protect password. I'm going to do that now. So this is 5 set to, you have to address mode, set it. Now I'm going to lock the EAS. Say click on the lock. It says this is forever. There's no undo operations here. Yes. Now the EAS, the whole EAS feature has been locked. Let's try to do all the things we did before. Activate and alarm, it's fine. Now I'm going to read the value of ES ID. Alarm, you got it. I'm going to send, get a random number. I'm going to set the ES password. Now we got the ES password set. Because we have locked the EAS, the tag will not let you change the ES ID. Let's try to do that. Set to say ABCD. Assume that I want a completely new ES ID. Say write. Now we got an error message. It is because even though we have the password, everything set, right? Because of the ES locking, you cannot make any changes to either enable, disable. Here the ES is enabled, you cannot disable. If you disable it, you got error message. Enable, you got error message. So what we saw just now is how the ES password works, and how to lock the EAS. Now if you have been following my videos all this time, somewhere in my early videos I have showed you how to protect EAS. So I would advise you to see that video. Now just have to keep in mind you can't undo this protect operations. And next I'm going to show you how to use this mask length. See, the main purpose of having the Eas Id is to identify a specific tag during the alarm command. So assume that I place the tag here. If I click on alarm, so what you do is what happens there is any tag in this tag in the reader vicinity will respond to this alarm command with 256 bits of memory. So bits of data. I can also, we know already what's the Eas Id. So by having this option flag set and click this alarm, you get this C3. Now, okay, I'm going to make a copy of this number. Okay, now I'll go back to this. I'm going to connect. And I'm going to send a command, the alarm command with the Eas Id. I'm going to use all the 16 bits of Eas Id. So I'm going to set the mask length as 16. If you hit alarm now, and first we'll understand what is the format of the command. So here we got the 42, this is the request flag, A5, this is the alarm command with 0 for the manufacturer code, and this is the mask length 16 bits followed by the mask. So you have to send how much of the EID you want the reader to match, you want the tag to match. Now we want all the tags, and see in this video, in all my video series, I'm using just one single tag. But in a real application, say for example, if you're in a library or if it's in a supermarket, if they're using IS-15693 tags, so where you'll be, the tags will be exposed to a bigger antenna and maybe hundreds of tags will be scanned. Okay, so that's a different process, but the basic concept, it's the same. So this could be the EID of a specific product group. It could be all the TVs, or it could be a specific item. Now if I change this thing, I'm going to change this to, I'm going to send invalid Eas Id and send this alarm command. So you get an error message because there is no tag in the vicinity which has got the Eas Id with the B1C0. So next I'm going to match just the C3. Now here the mask length is in multiples of 8, either it's a 0, 8 or 16. Now I want, even though you got a full B1C3, this time I'm going to have the mask length set to 8, and if you hit the send alarm command, now what has happened here is the software here is sending only the last 8 bits of the Eas Id to the tag. So any tag with the last bit as C3 will respond to this alarm command. Now in theory, if there are more than one tags with the same C3, there will be a collision. So assuming that no two tags will have the same last bit C3, or probably in a real system there could be some kind of a looping going on to check to send all the possible combinations of 8 bits, start from 0, 0, 0, 1, 0, 2. You can any tag that matches the last bit, the last 8 bits will respond with this alarm bit pattern. Now here, if you look at the command, the difference between this and this one, there is 1 byte less, because we are sending all the 16 bits, whereas here we are sending only the 8 bit. The least significant byte is sent here, and the response is the same. So I could have done just this one, C3, you still get the same response. If I change this to say B1, so I'm going to send the MS byte, the higher byte. So you'll not get any response because the 8 bits must be a lower byte. So go back to this and you get that one. Okay, I think that's all I got in this video. To summarize, in this video we covered everything about Eas Id. Thanks for watching.